Welcome back, guys, to Java Fanatics. Today we are going to have a session with primitive type promotion. Want to see the rules that applies to type promotion. But before we even go to the rules, I would like to explain what type promotion is. So type promotion, guys, is when the compiler automatically promotes a smaller primitive type for you to a bigger primitive type. So that is important because it helps you as a developer to lessen the work of having to provide an explicit cast. Imagine if that feature was not there. That means every time when you want to assign a primitive type, a variable, to another primitive type variable, you have to explicitly provide a task. But the compiler lessens that work for you, especially when you want to compile to assign a bigger primitive type variable to a smaller one. But when you do the opposite, the compiler does want you to provide an explicit cast. So without wasting much time, let's dig into the rules that applies to type promotion. The first rule is that when an arithmetic promotion is performed on two variables of different primitive types, the compiler checks which one is the bigger one in terms of bits, and it will promote the smaller one to the bigger one so that an operation can actually take place. Let's look at that in code. So what we mean is that we have two types. Let's say we have an int I equals to I. We have a short s equals to 9 as well. So when you do something like I plus s, the resulting type is an int in this case. Why? Because s is smaller than int, and so the compiler will promote s to make it an int, so that the whole thing will actually result in an int type. So this is what I normally do to verify that. So I always say, I use object. We know that, guys, object is a parent of all classes in Java. So I say object equals to I plus s. So there is another property or another feature that Java added in Java 5 that is called autoboxing. So what the compiler will do here, although the result here is an int type as a primitive, it will autobox that to a corresponding wrapper class, which is an integer. So how do I check that? So no, when I have done this now, just say object.class. So whatever that will be printed here, it's the resulting type here. So we know that it's an int type. So let's run this code again. So we see that the resulting type is an int. Although here the resulting type is an int as a primitive, like I said, because of autoboxing, this value gets promoted to a corresponding wrapper class. We know that all primitive types have their corresponding wrappers. We will talk about all such in our future tutorial. So let's change the type of int and make it long. So the resulting type in this case should be long. So we see that we have a long here. If we have okay, I'm not going to make an example using floating point numbers. I'm just gonna focus on these integral numbers for this particular rule, because the next rule will address the other conditions. So when a variable is floating point and the other one is integral, the compiler will promote the integral one to floating point. So this is what it means. So let's say here you have float. You see that float, guys, I is a float. So floating point numbers, as we mentioned in our previous tutorial, is a number that has a decimal point. So if you do this, then this becomes 7. But a short, you cannot say short dot something because it's integral. So in this case, the resulting type, guys, should obviously be a float because S is an integral and I is a floating point. So the type is the resulting type would be a float. If you put double here, it should also work, and it should print double because double is a floating point. If you put long and you put float, the resulting type would be a float. Although a long is actually, although long here, we know that long is 64-bit and float is 32-bit. One would have expected, according to the first rule that we mentioned, that the resulting type would be of a higher type. But we see that every time when there is a floating point number, it will always take that floating point number. So what this means is that we are losing some data here, because if long is 64-bit and float is 32, and the resulting type is float, that means we have lost some bits with a long, which actually technically means we have lost data. So this is what we can conclude here. So if we had a double here, d equals to 9, and we also set plus d here, it's obvious the resulting type will be a double. Why? Because double it's a bigger floating point. So this is what is going to happen here. So what the compiler will do for you guys here, it will say I plus z, because I and plus these two plus this they have the same operator precedent. So the compiler will start from the left and try to add I and z. It finds that the other one is long, the other one is float. So the resulting type for these two would be a float. The compiler checks, okay, now I have a float and a double. Then the type this resulting type will be promoted to a double. And then the double, we add two doubles, we have a double. So what the compiler will do will convert this I, will make it a float and add two float to get a float. And then the float plus a double, this resulting float will be promoted to a double, and a double becomes, the resulting types becomes a double. The third rule says a character, a byte, and short are first promoted to an int, even if neither of the operand is an int. So what this means is that, let's remove this thing. So if you have byte, you have car. So the fact that you are operating, alright guys, sorry for that. So we are saying that if you have a byte and a character, although neither of these two variables are of type int, the compiler will actually, for the fact that there is an operation that was done between the two, it will actually promote them to be an int. So the resulting type here, guys, will definitely be an int. Even if we put a short here, it's the same. Doesn't matter. As long as it's either byte, short, or a character, the resulting type will always be an int. So you can play around with this and you will notice that the resulting type will always be an int. The third rule says after all promotions have been done, the operands have the same type. There is another exception here with unary operators. When you unary operation on either byte, character, short, the result doesn't go to an int. It remains the same. So let's prove that. So if you say I, which is I minus minus, the resulting type here will be a short. So it's going to give us short here. If you put S here, it has to be character, wrapper class. You see it's a character. So if you put a byte here, it will be byte. Even if you do plus plus, the same thing. So what you can conclude from this is that the compiler obviously it has to be doing something like this on your behalf. It has to be actually autoboxing. No, not autoboxing, explicitly typecasting the result back to the initial type. This is what we can observe from what we are seeing here. And then the next rule says when assigning variables with a smaller type to a larger type, an explicit cast is required. From a smaller type to a higher, from a smaller type to a higher type, the compiler does automatic type promotion. So what this means is that if you have int f equals to I, the reason this works is because the reason why you are able to assign primitive type f to I, which is of type short, is because this short gets promoted to an int automatically by the compiler for you without you having to do anything. But if you try and do something like byte f equals to I, now the compiler complains. Why? Because now you are converting from a higher to a smaller. So in this case, the compiler wants you to provide an explicit cast, something like this. Sorry, to tell the compiler that you want to typecast this I back to a byte. But when it's the opposite, as we have seen, the compiler will do automatic type promotion for you without you having to do it. So guys, having mentioned all the rules, why is promotion important? Promotion is important to understanding what happens when you call an overloaded method, especially if that method is taking the parameters for that overloaded method. They are of type primitive or of wrapper class type. Okay, just one example before we end this video, so you can see what I want to talk about. So if you have byte b equals to 0, and you have public static void p and b, sorry, let me copy this. Then here, let's make it a short. And I want to print out so that we can see the type that was printed for us. So here we want to make it a short. So if we say PB, we see that there is no method here that takes a byte as a parameter, as an argument. And yet the compiler doesn't complain. This is where type promotion comes into place. So this byte will get promoted to a higher type, in this case, it's a short. So we are expecting when we run this program to get a short printed. We see short got printed. We change this to a character. We are expecting to get an int printed. Why? We all know that a character and a short, they both have 16-bit. So a character gets promoted to an int directly, and a short also gets promoted to an int. But when you move from byte, since byte is 8-bit, it gets promoted to a short, then to an integer. So this is why type promotion is important, guys. If you didn't know about type promotion, you are not going to be able to know which method gets called when the compiler looks at this. So know about type promotion. So if we don't have, let's say if we have an integer here, integer, and then we have, let's say we have short. We see that this one gets printed. So this is it, guys, about type promotion. I hope you enjoyed this video tutorial, and guys, please don't forget to subscribe. See you in the next video tutorial.